Hello everyone, and welcome to another part of the Galaga SDL tutorial videos. In this video we're going to be adding the player's firing logic. So we'll be creating our bullet class and adding the firing logic to the player class. So we can go ahead and get started by creating our bullet class. In our Galaga filter we will, what did I just do? We will add a new item, and this will be our bullet.h, so bullet. And let me just increase the font a bit. And then, if not defined, underscore bullet underscore h. Define underscore bullet underscore h. And then end f. We will need to include two classes in this class. The first one being our texture class, and the other one will be the timer, because we will need to translate the bullet and we'll need the delta time for that. So include texture.h and include timer.h. We will also be using the namespace quick SDL. And now that we have that set up, we can go ahead and get started on creating our class. So class bullet will inherit from our game entity, so public game entity. And we will need a few private variables in this class. So private, the first one will be a constant integer, which will be off screen underscore buffer. And this will be equal to 10, because we need the bullet to disappear once it's off screen. So we'll give it about 10 pixels, so that if it's off screen at the top or the bottom by 10 pixels, we can just disable the bullet. And next up, we will need a timer pointer, and timer for our delta time, and a float m speed, which will be the speed of our bullet. And finally, the last variable that we'll need is the graphics for the bullet, which will be a texture pointer. So texture pointer, m texture, and these are all the variables that we'll need in this class. Next up are the functions. So public, we will need a constructor and a destructor, so bullet and bullet. And we'll also need two functions. One will be firing and reloading, so void fire, which will take a vector2, we'll call this one position, so that, and void reload. So whenever we want to fire a bullet, we will call this function, and when the bullet is off screen or it hits an enemy and it disappears, we can just call the reload function to get ready to be fired again. And then we will have the normal functions that we usually do, so update and render, so void update and void render. And that will be it for our .h file. Now we can go ahead and get started on our CPP. So we'll go to our Galaga filter, add new item, and this one will be called bullet.cpp. And then here we will include bullet.h, and then create our constructor, so bullet. And in this constructor, the first thing that we need to do is to initialize the timer. So mTimer is going to be equal to a timer instance. And then what do we have here? Our speed. So mSpeed is going to be equal to, let's say, 500, because it needs to be moving pretty fast, a lot faster than the player is moving. And finally, the last thing that we need to use is the texture pointer. So mTexture is going to be equal to a new texture. And over here, I already have a texture for the bullet. So it's just a texture with just the bullet in it. So this one is called bullet.png. So we'll load bullet.png. And we need to center this texture onto our class, or onto our bullet object. So we'll say mTexture parent is this. So parent is this. And mTexture position is just going to be zeroed out. So vector2 underscore 0. And that should be it for our constructor. The last thing that we need to do is to call our reload function to get our bullet so that the bullet is ready to be fired, because we're going to be reusing these bullets. We don't want to create a new bullet every time we want to fire a bullet. So we'll say reload, and this will be it. Now to move on to our destructor, we'll do bullet destructor, and all we need to do is set timer to null and destroy our texture. So mTimer is going to be equal to null, and delete mTexture, then set our texture to null. So mTexture is equal to null. And this will be it for our destructor. Now we need to create our fire and reload functions. Bullet, that's a void, bullet fire, and that takes a vector2 position. And the position is where we want to set the bullet once it's fired. So we'll set our world position to that position. So we'll call our position function for that. And set our active to true. This will be it for our firing. Now the reloading, we'll just set our active back to false. Void bullet reload. We'll set our active to false. And this will be it for these two functions. Now the last thing that we need to do is to implement our update and render. So void bullet update, and in update we need to check whether we're active or not. So if active, what we want to do is to translate along the negative up axis. That's because our bullet, the texture is pointing upwards. So we'll do translate, and in SDL, up is actually the negative direction. So we need to do negative. We'll be translating along the negative vec2 underscore up, multiplied by our mSpeed, multiplied by our timer delta time. And this will be it for the translate. But we want to change our translate function a little bit, because right now all the translation that's being done is done in world space. But if our object is rotated, we want to translate. So let's say our object is rotated by, so our bullet is rotated by 45 degrees. We want it to translate along the 45 degrees axis. And to do this, we need to specify if we want to translate along world space or local space. So we need to open up our GameEntity.h and go down to our translate function. So in translate, we want to add a space as well to it. So a vector and a space. So space, space. And then in the CPP, so GameEntity.cpp, we'll go down to translate and then add the parameter as well here. So space, space. So far we've been using the world space. So we can say if space is world, we can just do what we were doing before. So just translate, increment the position by the vector. Otherwise, what we want to do is to take this vector, transform it into local space, and then increment by it. And we can do this in just one, just a single line. We can say in position plus equals rotate vector, and we will rotate this vector, which is vec, by our world rotation, so the total rotation of our object. So rotation, and rotation by default, the rotation function returns world rotation, so we can just say rotation. And this will be it for the translate changes. Now we can compile to see what errors this caused. There we go. So it's 4 different instances where we use the translate function. The first one will be our bullet.cpp. So our bullet, we wanted to translate along local space, so we can do local. Next up is in star.cpp, in the scroll star. So it's much more efficient to do it in world space for this because we're not rotating the stars. So we'll say world So translate along vector 2 up and using the world space. Next up are the players' right and left translations. So over here will be world and world as well. Because we're not rotating the player, so we don't really need to say that it should be local space. And that will be it for all these changes. If we try to compile, we should have gotten rid of all the errors. This is just complaining about the render. We'll implement in a second, so that's fine. So these are all the instances where we're using the translate. Now we can go to our GameEntity.h again and set the default to be local, because usually we will want to translate along local space. Transforming along world space should be something that shouldn't be done all the time. So over here, we're translating along local. It's by default local, but it's fine. We can just say that it's local in here. Now we need to check the bounds to see if the bullet is off screen or not. So we can say vector2 position is going to be equal to our world position. And then if the position.y is less than our buffer amount, which is 10, so negative off-screen buffer, or the position.y is more than the graphics instance screen height plus our off-screen buffer, so off-screen buffer. So if it's off-screen, we want to just reload it. So we'll say reload. And that will be it for our update function. Next up is our render. And all we need to do in render is to check if it's active. We draw the bullet. So void bullet. Render. If active, mTexture render. And that will be it for our bullet class. Now we have all the functionality that we need. We can go back to our player and add the firing logic. So we can go back to player.h and include our bullet.h. So include bullet.h. And usually in Galaga, we only had 2 bullets to fire. So if you fired and the bullet disappeared, you can fire again. But if you have 2 bullets on screen at the same time, you can no longer fire. So for that, we just need to make an array of size 2. So over here, we'll say static const int max underscore bullets, and this will be equal to 2, and a bullet pointer in bullets, and this will be of size max underscore bullets. And this is all we need in here. Now we can go to our player.cpp and initialize these. So in the CPP, in our constructor, over here, we can say that we want to loop through that array, because we have our size here. We can loop through and create these bullets. So in player.cpp, for int I equals 0, I is less than the max bullets, I plus plus, and bullets at I is going to be equal to a new bullet, and this will be it for that. Now we can move on to our destructor. We can do for int I equals 0, I is less than max bullets, I plus plus, and then we will do delete m bullets at I, and m bullets at I is equal to null. And that will be it for the destructor. Now what we need to do is to update and render them, and if the bullet is fired, whether the player is dead or not after it's been fired, we still need to update it. So we can do outside here, so outside all the if statements, for int I equals 0, I is less than max underscore bullets, I plus plus, m bullets at I update. Probably don't even need these brackets. So update, and then we'll copy these two lines and then add them right here. But instead of update, we will render them. And we're doing this without checking if the bullet is active or not, because we're already doing this checking in the bullet.cpp. And so now we created the bullets, we're clearing them in the destructor, and we're updating them and rendering them. The last thing that we need to do is to fire them. And to do this, we need one more function in the player. So it will be a private function, and we'll call this one void handle firing. Now in player.cpp, we will do handle firing right here. So whenever we're moving, we can also fire. So we can do handle firing in here. So that's an update if active, handle movement, and handle firing. And then we can go right underneath handle movement and add our handle firing function. So void player handle firing. And there we will do if the input key pressed is space, so SDL underscore scan code underscore space. So whenever we hit space, we need to check if there's an active, if there's an inactive bullet or not. So for int I equals 0, I is less than the max underscore bullets, and then I plus plus. If not, so if the bullet is not active, in bullets at I active. So if the bullet is inactive at the time, we want to fire that bullet. So in bullets at I fire. And the position will be our current position. So we can just pass in our position function. And then we will also need to play the firing sound. And I have a wave file with the firing sound here. So there we go. And we can just use the audio manager to play this. So it's called fire.wave. Where was I? Right here. So audio, play SFX, and this will be called fire.wave. And that will be it for firing. The last thing that we need to do is to break out of this loop, because we already found a bullet to fire. And if we don't find any bullets to fire, because the bullets are still active on screen, so they haven't hit an enemy yet, and if they didn't go off screen, we can just wait for a bullet to be inactive. And that will pretty much be it. Let's run it and see if it works. There we go. So that compiled, and the game is starting. There we go. And if I press space, we are firing, and we can only have 2 bullets on screen at a time. If I keep pressing space, it only fires 2 bullets, and that's it. Now, the bullets seem to be pretty slow, so we'll go back to bullet.cpp and change the 500 to 1000. So that should be fast enough for the bullets. There we go. Yep, and that seems pretty good. So now we have our bullet firing, and if we want the player to be able to fire more than 1, we can just change the max bullets to like 3 or 4. But in the original game, it was only 2 bullets at a time, so we'll keep it that way in our game. And that should be it for the player firing. Next video, we will start working on the enemies. And there's one more thing I wanted to show you, is that if we rotate the bullet now, it will actually be translating along its local up direction. For example, if I do something like rotate by 45, but you don't need to do this. It's in the bullet constructor. I'll just add it here to show you, and then I'll take it out in a second. But so we rotated the bullet by 45 degrees. So when it fires, it should be firing off at a 45-degree angle. There we go. So as you can see, it's firing in whichever direction it's translating along whichever direction it's looking, because we're using the local axis to translate. So now we can remove that, and this will be very useful for the enemies, because now when we want the enemy to rotate or move in some complicated pattern, we can just rotate the enemy and it'll just translate along its up direction locally. So this will be it for this video. I really hope that it helped. If you have any questions, suggestions, or feedback, please leave them below. Otherwise, thank you very much for watching, and I will see you in the next video.